This particular model is where the AC comes straight out of the up into the top instead of going through the reset. This is where we make our connections. These same connections would be inside this reset housing. The interconnect going downstairs. As we come downstairs, we'll go ahead and wire in the valves. These are light wires which we actually marked earlier. My purple wire is going to the neutral for my large valve, which on the Bennett, the large valve or any large valve is always the valve with the 3 copper tubings. That's your large valve. Your small valve is always the one with only 2 copper tubings. The purple goes to my large valve neutral. Ready?
Yep.
Yellow in the coming off the CPU of the VRR goes to my small valve neutral. The 2 valve AC pots will go to my red wire coming through my relay that's in the top. What we do is power one side of the relay with 110 volts. Now we recommend that the units be run on 2 circuits, one for the motor and one for the AC power for the electric reset, or actually the VRR CPU. If you want to, you can also run the lights on that if you only have 2 circuits available. Or you can tie them in with an additional neutral to your lights in the pumps or onto your canopy light.
So the Bennett valves always have those blue and white wires, and we're going to use the blue wires for the AC hot connection. They're going to have a common AC hot tied to that red wire that Dave talked about earlier. The other red wire is going to be tied to a hot that you would have connected to your breaker box, that you cycle power to your pump motor that way. This is a working shop. We're cleaning some parts over there, drilling some holes, grinding some things.
And one side of my motor.
So that'll require a larger wire nut. Alright, we've got our pump motor hot, valve hot, tied to the red wire coming out of the reset to switch the hot down to the motor and the valves. This other red wire is going to be used to supply the hot that we're going to be switching. Got our neutral for a fast valve. We're going to tuck that back in. You see the light circuit hot and neutral are taped together like he talked about earlier. Now we've got another black and white that are not tied together. That is the CPU head power. And if need be, you can wire nut all those to the same circuit if you only have 2 circuits running the pump. This is the cable that connects the CPU to the display boards that are going to be that replace the VR10. Comes potted. You may have to make this hole a 3/4 inch. Sometimes it comes 1/2 inch. On later models, it'll have a 3/4 inch hole already set for you. It's got the 3 mounting bolts included in the kit. They match up with the 3 holes that you remove the VR10 from, or the Vrr computer. What you're going to want to do is keep those 3 bolts loose when you first put it in, to allow you some wiggle room to align the pulsar meter connection kit as vertical as possible between the meter and the pulsar. We got your display cables connected down below. We're going to make some adjustments on this and tie that longer bolt into the electric reset.
The white.
So we connected it into that tab on the reset housing. There's also going to be a little small screw that you'll run through that standoff and into a nut and washer. No, actually it's a screw going into a threaded post on the support bracket. This rod and this coupler are the Bennett meter coupling kit. The rod comes long enough for you to adapt it to any meter spacing between the meter and the bottom of the pulsar where it's going to hook up. This rod goes into the top of the meter. This coupler will hook into the pin that's on the pulsar, and you'll put the pin through this slot. It comes with some set screws. Once you get your rod height measured, you can use some calipers if you have them. You can put your measurement on there, find out your rod length, and then trim it with a hacksaw. Dave's cut a shaft to size. He's gonna slip that coupler up over the pin on the pulsar. He's gonna try and align that thing so it's straight as possible. We'll move this the U-frame display kit to align it the right way. And then you'll use those set screws to attach the coupler to the shaft.
What the hell's going on here?
What you want to do is not have that shaft resting on the top of the meter. You want it to kind of float. Isn't that right, Dave?
Yeah. I can't get this thing to go on now.
We've got a 1/4 inch spacing between the bottom of the pulsar and the top of that shaft. And then what he'll do is he'll run that coupler up the shaft on the pulsar and tighten his set screws up. Alright, we've got our meter coupler kit installed. We've got our handle switch connected, shaft connected it into the reset housing. One thing you want to do is make sure that this works smoothly and that you don't have it's not too loose. It wants to fit in there kind of snug. If this reset housing is out too far, that pin has a tendency to fall out. So you want to try to make your adjustments so that it's unlikely that pin will fall out of this connection. All right, we've obviously we don't have any control wires going in the building. We've just got a cheater cord in here. We've got the unit powered up. It's showing 0. The default price is 1234. And on the board, we've got some lights. This flashing light right here is the heartbeat light. That tells you that the software is running and the board's operating. This light here is your power light. That tells you that there's at least power getting from the AC input through the transformer and into the regulator lighting the light. This light that's here that's on steady, that's the receive light. If this board was hooked up communicating to a pump controller, that light would be flashing in the receive fashion, and when it starts communicating, then the transmit light right next to it would start flashing. Right now we've just got it running in standalone. Just wired hot. You can check the operation as you switch. The pump should automatically reset, do the segment check, and you're ready to start pumping. You turn it off and everything cuts off. Now I'll show you what happens when you turn it on. The very first thing you're going to see is that motor light just turned on, and after reset's complete, the slow valve is going to kick in, and the fast valve light, and the fast valve will not get activated until just now when we simulate pulses going through there. It takes about 4 seconds, 4 pennies for the fast valve to cut on. Anytime you stop pumping, the fast valve will turn off and won't turn back on until you start pumping again. That helps when you're topping off the tank. Helps you try to staff at an even dollar amount.